A pleasant peacetime learners. This is again Sir Peter, your pre-calculus teacher. We are still on week number 4, which talk about the hyperbola. And for this video lesson, we will talk about the standard equation of a hyperbola center at the origin. So at the end of this video lesson, you should be able to illustrate the standard equation of a hyperbola center at 0, 0. So let us define again what is a hyperbola. According to the definition, it is a set of all coplanar points such as the difference of the distances from the two fixed points is constant. So notice the word difference because this is one of the characteristic of the distances of the focus. So there is a constant difference from the distances of a point going to one of the foci and from a point going to one of the foci. So we simply subtract these distances to get a constant distance. Let us observe these given points on the figure 1.23. So observe the two fixed point of the hyperbola with branches to the left and to the right. Notice that the center is located at the origin. And observe the coordinates of f sub 1. The coordinates of f sub 1 is -5, 0. While the coordinates of f sub 2 is 5, 0. Now, let us obtain the distances from one of the foci going to point A. So look at this distance. So that is A f sub 1. Using the distance formula, we will have the square root of -5 minus 3.75 squared plus 0, the quantity 0, minus -3 squared. So we will get 9.25 minus 3.25. Then following the formula, we get the absolute value. So that is +6. And the absolute value of +6 is 6. Notice that 6 is our distance to A because from 0 to -3 and from 0 to 3 is the distance, which is what we know as the transverse axis. So it is equal to the transverse axis. Let's have another point. Suppose that we form the distances between point f sub 1 going to point B and f sub 2 going to point B. So that would be the absolute value of bf sub 1 minus the absolute value of bf sub 2. The distance here is 5.33, as you notice, minus 11.33. So getting the absolute value of the distances, that is -6, and the absolute value of -6 is still +6. Notice that it is still represented by 2a. So therefore, the constant difference that I am referring to is the length of the transverse axis 2a. So the distance from v sub 1 to v sub 2, which are the vertices of the hyperbola, is our constant distance. And that is obtained by getting the difference of this distance to this distance. So in statement, we say that the absolute value of pf sub 1 minus the absolute value of pf sub 2 is equal to 2a. That is why when we form the standard equation of the hyperbola, notice that it seems like the standard equation of an ellipse, because an ellipse has a sum, right? But in here, the only different thing is the sign. So it now became minus sign. And notice that a squared and b squared does not change position. But for a horizontal and a vertical hyperbola respectively, what we look at is the x part and the y part, which interchange. Notice that for a horizontal hyperbola, the y part is negative. And for a vertical hyperbola, the x part is negative. A squared is the square of the semi-transverse axis, while b squared is the square of the semi-conjugate axis. But notice that A and B are the two shorter distances in a hyperbola, because which is the longest distance? It is the distance C, which is the distance from focus to focus here. So that is the longest distance. So to get the value of C, simply get the square root of A squared plus B squared, just like the formula of the Pythagorean theorem. And to get B, we subtract it from the longest distance, that's C squared minus A squared. And to get A distance, it is the square root of C squared minus B squared. In your self-instructional pockets, you can see the summary of all the formulas that you could use. Not always remember that the vertices, the foci, are collinear with each other. That's why they will share the same x coordinates when the foci are on the x-axis. And when the foci are on the y-axis, look at this one. The coordinates are on the coordinate. While for the endpoints of the conjugate axis, it is located on the y-axis. While in here, it is located on the x-axis. So the transverse axis for a horizontal hyperbola is the x-axis itself. While in a vertical hyperbola, it is the y-axis itself. For the conjugate axis of a horizontal hyperbola, it is the y-axis. And for a vertical hyperbola, the conjugate axis is the x-axis itself. Remember that these formulas are for center is at the origin. The directrices also has formulas, but these are not that important. For the length of the latus rectum, do not forget that we still use the formula 2b squared over a. That's why one of the endpoints will have a formula positive, negative, b squared over a. And one of the most important parts of the hyperbola, although it is not really part of the hyperbola, but it's close to the hyperbola, it gets closer and closer to it, are the equations of the asymptotes. For horizontal hyperbola, the equation of the asymptote is y is equal to positive negative b over ax. And b over a is the slope of the asymptotes. So the asymptote that leans to the right is the positive, is with a positive slope. And the asymptote that leans to the left is the negative slope. Same is true with the vertical hyperbola. You just interchange the value of a and b. So for a horizontal, it is b over a. For a vertical hyperbola, it is a divided by b. So let us apply these formulas now to answer this problem. So for our illustrative example, let us find the coordinates of the foci, the vertices, the endpoints of the conjugate axis, w sub 1 and w sub 2, and of course, the equation of the asymptote. Given the hyperbola with equation x squared over 16 minus y squared over 9 is equal to 1. Based from this given example, since the x part is positive and the y part is negative, what type of hyperbola do we have? Very good. This is an example of a horizontal hyperbola, center at 0, 0, or center at the origin. The next step is to determine the value of a. Now, to get a, simply get the square root of 16, because on the formula, the first number is a squared. So the square root of 16 is positive, negative 4. What about for the b? Simply get it under y squared. So that is positive, negative 3. And how do we get the c distance? We have a squared plus b squared. So the square root of 16 plus 9 is the square root of 25, which is positive, negative 5. So this is now our c distance. Now, to get the coordinates of the vertices first, we refer to the distance a. So since the vertices are located on the x-axis, so we have negative 4, 0. Then we have 4, 0. So a lot of people are asking me if it's okay if they will interchange. So Sir Peter is just forming a pattern. So usually I write the negative first and then the positive. But you could interchange the vertices, whether you want it to be positive first or negative, for as long as you follow certain patterns. And since the vertices are collinear with the center at 0, 0, and the foci, so therefore, the foci will be located also on the y-axis. So for f sub 1, we have negative 5, 0, and 5, 0. For our endpoints of the conjugate axis, we have w sub 1 with coordinates 0, negative 3. Now, why did the format of the coordinates of the endpoints of the conjugate axis different? Because the conjugate axes are now located on the y-axis. So it's the reverse. So the location is at 0, negative 3, and 0, 3. And lastly, let us solve for the equation of the asymptotes. Remember that the equation of the asymptotes is positive y is equal to positive negative b divided by a times x, which is only true for horizontal hyperbolas center at 0, 0. Substituting the values, the first asymptote, which leans to the right, is 3 over 4x, while the other asymptote, which leans to the left, is negative 3 over 4x. So this is how the graph looks like. So again, let us check. This blue line here, this one. Oh, sorry. That blue line there, this one, is what we call the length of the conjugate axis. Well, this one is the length of the transverse axis, which is 4 units. Okay, so this is 4 units and this is 3 units. And where is the focus or the foci located? It is located here. This is F sub 1 and this is F sub 2. These are the W sub 1 and W sub 2, where the endpoints of the conjugate axis is. Do not forget that the auxiliary rectangle can be drawn here. So that the endpoints or the vertices of the rectangle will form the asymptotes. So again, this is this red line is the asymptote, which is the negative with the negative slope. That is y is equal to negative 3/4 x, and this one will be y is equal to 3/4 x. Okay, so that is how we illustrate the parts of a hyperbola, a horizontal hyperbola center at 0, 0. Let's have another example. Give the coordinates of the foci, the vertices, and the endpoints of the conjugate axis, the equation of the asymptotes of the hyperbola with equation y squared over 25 minus x squared over 144 is equal to 1. Notice that in here, in the given example, the x part is negative. Therefore, what type of hyperbola do we have? Very good. The answer is a vertical hyperbola, center at 0, 0. Always remember that when the hyperbola is vertical, these has branches which opens upward or downward. Unlike the other figure, which is a horizontal hyperbola, those hyperbola are hyperbolas with branches to the left and right. So this time, the graph will be different. So it is also important to determine now our distance A and B based from the formula. So the first part of the formula with y squared is our A. So what is the value of the square root of 25? Correct. It is positive negative 5. What about b squared? So this time, b squared is positive negative 12, which is the square root of 144. And how do we get again the distance C? Just like the Pythagorean theorem. So we have, I'm so sorry, let us correct that one. A squared plus b squared. So we will have the square root of 25 plus 144. And that would be the square root of 169. Remember, 169 is a perfect square. So we will have positive negative 13. Now, we can now determine the coordinates of the vertices v sub 1 and v sub 2 respectively. Again, you can interchange either the positive or the negative signs, but for uniformity, Sir Peter is going to write first the negative signs. So for this reference, for a vertical hyperbola, the vertices are located on the y-axis. So the abscissas have no value, so it's 0. And we now get negative 5 and positive 5. And since the foci, f sub 1 and f sub 2, are collinear with the vertices and the center at 0, 0, then they share the same format. So again, the abscissas are 0, and you simply get the C value that is negative 13, and the other value will be positive 13. Now, for the endpoints of the conjugate axis, these points are now located along the x-axis. So the abscissa has values the same with B. So that will be negative 12 and 12 respectively. And for the ordinate, it has a value 0. Now, for the equation of the asymptotes, we use the formula y is equal to, this time, it's A divided by B. So that would be, do not forget the plus and the minus sign. So the answer is y is equal to, the first one is negative for a slope leans to the left. It's negative 5 over 12x. And if you want to write the equation of the line with slope positive and it leans to the right, it is positive 5 over 12x. So these are the equation of the asymptotes. Let us illustrate it now using Symbolab. This is the sample graph. So notice that the hyperbola is represented by the green line, and that green line opens with branches upward and downward. So this is our the conjugate axis is this line, that one, this one. Yeah, this one. That is the conjugate axis. And the transverse axis is this one. For the focal axis, it is somewhere located. So this is 5. And yeah, somewhere here. So if this is 5 units, then we'll have 10. Yeah, somewhere here. This is where the focus is located. Somewhere there. So this is your f sub 2, and this is your f sub 1. Now this gives us the value of it's 12, so somewhere here is our w sub 1 and w sub 2. We can form the auxiliary rectangle right here, forming the asymptotes. So that is how important the auxiliary rectangle is. And again, the given is center at 0, 0. The v sub 1 and v sub 2 are located here also. So these are the important points of this illustrative example. Y squared over 25 minus x squared over 144 is equal to 1. Always remember that C is the longest distance, and to get it, you need to get the square root of A squared plus B squared. And C is greater than A, as well as C is greater than B. Number 2, in a standard equation, if the x part is positive, do not forget that the hyperbola is horizontal. And if the y part is positive, the hyperbola is vertical. Vice versa, if the y part is negative, the hyperbola is horizontal. And if the y part is negative, the hyperbola is vertical. For the distances, the transverse axis is 2a, the conjugate axis is 2b, the focal axis is 2c. A distance is the semi-transverse, the b distance is the semi-conjugate, and c distance is the distance from center to one of the foci. So here are the references used in this presentation. Did you learn something for today? So for our next video lesson, we are still on week number 4. We will now talk about the standard equation of a hyperbola centered at age k. So this is Sir Peter, your virtual pre-calculus teacher.